Welcome. I'm Harsha. I'm from Hasura. Welcome to the NestJS workshop. We're going to have Jesse Carter here, and we also have Gavin Ray from Hasura who are going to be leading it.
That's awesome. And it's definitely a pleasure to be here. I'm excited to be sharing some stuff about two technologies that I'm really excited about, NestJS and Hasura, obviously. So I'm currently a senior software developer at Circadian Risk. We're a startup that's focused on some really exciting stuff around disrupting the physical security industry and just really digitizing some kind of more archaic processes, bringing that in the modern age. We use both Hasura and NestJS at work. And like Gavin mentioned, for his personal projects, I also reach for both Hasura and NestJS for kind of any side stuff that I pick up. I think that they form the foundation for a really compelling full stack backend kind of framework pairing. We are hiring right now, so if anything that we go through today is exciting to you and you're looking to get more involved with these technologies, please check out Circadian Risk, get in contact with us, and we'd love to hear from you on that front. Just like a brief, I guess, synopsis. We're going to be covering a fair bit of content in the workshop today. I know that there's kind of a split in attendance here between people who might be coming from a NestJS background and are interested in hearing kind of more about Hasura and how it fits into their existing applications. And vice versa, I know there'll be people coming from the Hasura side who are looking at ways to integrate NestJS as a means to kind of implement some backend business logic and just kind of deeper integrations and a more complete application. So bear with me, I guess, we're going to do a quick section on each. So bear with me if you're familiar with one. I'm going to try my best to kind of cover like the very high level stuff so that you kind of get the why should you care aspects of each technology answered for you. And then we're going to dive right into like a reference application that I'm excited about. Cool. So I'm going to quickly just set the stage by just opening up the project repo here. So today in the workshop, we're going to be demonstrating how we can build complex applications using integrations between Hasura and NestJS. We're going to look at actually 4 different ways that we can kind of integrate these two technologies together. We'll be using Hasura actions, remote schemas, event triggers, and also some scheduled events. And we'll cover the pros and cons of sort of the different, each individual one as we go through the workshop. And for the actual app itself, I tried to come up with something that would kind of allow us to explore some deeper business logic and integration. So we're going to be building a fictional digital marketplace. And the idea here is that users who register can basically create items for sale. And those items will just have like some secret information inside of them. It'll just be a column in the database. But in order to view someone else's item, you obviously have to purchase it first. So in our application, each user is going to start off with 50 coins to start. And basically, the kind of core of the thing we're going to get to is that when we go to purchase, or when a user goes to purchase an item, we need to make sure that we're safely subtracting the account balance of the cost of that item from the buyer's account and adding it to the seller's account. And we're also going to skim 1 coin off the top as a processing fee. So obviously we need to be concerned about things like database transactions here, making sure that a user actually has enough coins in their account in order to make a purchase. Otherwise, nothing should be modified.
Yeah, super quick tip, Jesse, could you press period on this page really quick?
Yeah, absolutely.
Just to show. So if you may not know, for whatever reason you can't follow along, you don't have Docker or anything installed, you can press the period key on your keyboard and it'll open it in an in-browser VS Code. And that way you can at least try to follow along some of the source material a little bit easier.
Yeah, very cool. This is kind of a mind-blowing for me new thing that GitHub and Microsoft have put out. So very cool stuff. So I'm going to quickly cover just a little bit more to try to drill into the application schema we're going to be dealing with for our reference application. And that'll set the stage for us to take a little bit more of a look at Hasura. So it's pretty straightforward as far as there being 3 key tables that we're caring about here. We've got our users table, and a user can create an item. All items must be created by a user. That's how they make their way into the system. And at creation time, a user will provide sort of the secret value. This is the thing that we're selling. And so we'll be protecting very carefully this column unless a user has actually made a purchase of that item. Any questions high level about this, this database diagram before we jump right in?
So far in the chat, we do not have anything. It looks like if you have a question at this point in time, feel free to post it and we can address it. Otherwise, we'll move on and guess about, like 15 or 20 seconds. Could you share? Okay, yeah, I'm gonna post the GitHub repo again. Somebody's asking. So
yeah, it should be in the chat history, but if you'd post that again, that'd be great. And yeah, if you want to follow along, please feel free to clone this. I should mention here that what's currently on the master branch is sort of the completed project that we'll be working towards. So if you are following along, I'm going to be starting from a branch called starting. So just check out that if you clone the repo.
And then we have a question, items.userid is the one who created the item?
Yeah, that's correct. Yeah.
All right, that looks like all we have for the moment.
Great. So yeah, I've got the project running here. I'll pull up the README, and everything that you need to get started is already included in the repository. So basically all we need to do is install our dependencies here with Yarn, which I've already done, Docker compose our services. So the two services that are provided for you in the repository are a Postgres image running Postgres version 12 and Hasura running the GraphQL engine 2.0.7. Now, the really neat thing about Hasura is that it basically provides real-time instant GraphQL over top of your database. So Hasura doesn't care how the schema came to be. The database can exist in an existing application and you can immediately start to leverage Hasura, or it can be for something greenfield like this. In the case of our reference application here, the migrations for the database are actually managed by Hasura. So there's a migrations folder. We won't go over like the SQL statements here. The diagram kind of covers what we're setting up. But if we just want to apply the migrations, if you're following along, you can just run yarn Hasura migrate apply, and that'll get you basically the Postgres instance set up with all the tables pre-created for you. So just as an example here, I'm connected to the database here. You can see that if I make a query to get information from the users table, that data is obviously returned to me. Now, what Hasura has already done based on this setup is connected to our database and basically introspected the tables and made available to us a GraphQL API that we can start using to make queries against our data, insert data, manage permissions for different roles and things like that. If you're following along, the easiest way to kind of get to this next step with me is that you can just run the yarn Hasura Console command, and that should spin everything up in a browser window for you. So you'll basically arrive on a page like this, and this is the Hasura Console for those of you who are familiar. I'm sure you know what this is, but we'll do a quick review of kind of what's in here for first-time users.
Can we do a little bit of zoom on all of the
Yes.
windows that we're working in?
Okay, so landing in the Hasura console, I'm going to quickly visit the data tab, and basically this screen shows us which tables from our database are already available to kind of interact with over the GraphQL API that Hasura provides out of the box. So you can see that there's basically tracked information for our items, our purchases, our users. And this allows us to basically use GraphQL to interact with this data. So if I wanted to do a similar query to what we saw in my database terminal in the other window, I can just grab like, what are all the users' display names in the database? And you can see that immediately get that information back. So Hasura is making all of this available on an API endpoint that can be consumed just as easily in this administrative console as it could be in like a user-facing application. So it gives you basically CRUD sort of out of the box ready to go for free. On top of that, there's some really neat functionality around subscriptions that I think are worth quickly showing. So if we wanted to have a real-time view into data that's inside of our database, we can do that through subscriptions. So I could do the same thing. I could say, let's grab the emails of all the users in the system. And Hasura sits on top of the database itself. So if I make changes to the data, it's not critical that that change happens through Hasura. It will still be reflected just by virtue of the database being modified. So if I, for example, put myself in here, oops. You'll see here that in the other window, immediately this record pops up. And that works for pretty much any kind of view of your data that you want to have access to. And it's a really, really powerful feature of Hasura to build real-time reactive applications, especially if you're connecting this to like a front-end application. Let's see what else. The tables that are exposed are up to you. It's not required that like essentially your whole database is exposed. You can be very granular about, if you're only wanting to expose a subset of information from your database over the GraphQL API, that's all easily managed. Hasura will automatically pick up tables and views and other database objects that exist inside of your database. And it'll give you the option to track those and basically make them to be a part of the GraphQL API. So you can see here that in my database, I've got a view called public users that's not part of my schema yet. I can't query for it. If I try to get to public users, it's just not a thing that exists, even though the database has this as a view. So if I choose to track this, it basically becomes part of Hasura's managed understanding of my of my database. And it gives me, now like a little tabular view of the contents of that view. And likewise, this refreshes, and I can now query the contents of that table, or that view, I should say, public users. Display name. So really powerful stuff here. You can be, very granular about the stuff that you want to expose. It can be used for greenfield projects, or it can be used to basically like expose a real-time API over an existing database that you might have as part of your project. I guess the last thing I'll quickly show here, because it'll be important for the rest of the demo, is that Hasura has a really powerful permissions system that allows you to describe what users or what roles users should be able to have in order to interact with the different data. So for example, in our database schema, we talked about how, this secret value, it's important. It's the thing that our users are selling. So obviously we don't want a user who hasn't purchased an item to be able to read this secret value unless they've made that purchase, or if they're the person who created that item, they should be able to obviously see their own. So Hasura has a row level security model for us to be able to basically describe what conditions should be met in order for a person to be able to access that data. So if we go to the permissions tab for our items table, you can see that this is broken up across different CRUD actions here. So insert, select, update, delete. And for selecting, for example, and this is part of the starter kit, so it's embedded in the repository if you want to get to this point. We can see here that the permission system basically allows us to describe access based on relationships that the person making the request to the Hasura API has with our data. So there's kind of two conditions we talked about, modeled with an or statement here, and there's a visual builder for this. So, or the user ID of the item matches the user making the request, which just means that they made it. It's their item, they own it, they should obviously have access to it. And secondly, if there are purchases associated to that item and the user ID on the purchase record matches the ID of the person making the request, then that should also allow us to see the data, or that user to see the data. We can see this really quickly with impersonating roles and users in our console here. So I'm currently querying from the perspective of a sort of a super user. My view of this data is not restricted in any way, but obviously that's not the way we would expose the GraphQL API to end users or for end applications. So we'll get into a little bit more about like how we embed these claims inside of a JWT when we actually implement the app. But the kind of key takeaway here is that on a per request basis, Hasura allows us to include information in the request itself about the nature of the person asking for or attempting to modify data. So for example, I guess I'll have to quickly insert an item for us to be able to look at this. So if I wanted to insert an item and attach it to our first user here, let's say that the secret is Hasura Rocks, and the cost to access this secret will be 20 coins. I can save this. Oh, I should give it a name. My first item. So again, this was associated to user ID 1 as the person who technically owns, or we can imagine that they created this. If I go back to the API here, I can send a request as if I were user ID 1 and with the role user. And now whenever I interact with the API, so any query or mutation that I send is being evaluated against those permissions that we've defined. So if I look for items and I want to get the secret, I can see this one because I am the user, or this person making the request is the person who owned it, user ID. So I can get it. But if I were to make that request as user ID number 2, who is the second record that we entered here, you'll see that for the exact same query, I get nothing back because that permission check evaluates to false. And obviously that's the desired goal here as far as access to this information. So that's my, I don't know, 10, 15 minute introduction to Hasura. Hopefully, if you're coming from the NestJS background, there's some exciting stuff in there for you. It's definitely a powerful system, and we're going to be diving into that obviously more. But if there's any questions at this point about Hasura, Gavin and I will be definitely happy to try to answer those for you.
At the moment, we have nothing that's been put into the queue. Again, we can kind of pause for another 15 or 30 seconds if people want to raise questions right now before we move on sort of to the Nest part. Okay, so we have also, just so you folks know, Zoom does a weird thing where when you send messages, it doesn't always send to everybody and it sends to DMs. So you may be DMing someone. For example, Jesse can't see this, but someone had just DM'd me. Can a user carry multiple roles for the query?
Yeah, so there's a couple options here, and you might be able to speak to the new, I think it's still behind an experimental flag for the multi-role support. The token can basically describe that a user could be one of many roles, and it's very simple if you're making a query to just say, I want to do it as user or this other role, but there's a way more powerful feature that Hasura has been working on that. I don't know if you wanted to take a couple minutes to quickly talk about, Gavin.
Yeah, so the high level of it is that we have something that we call role inheritance, which is basically exactly what it sounds like. The idea being that you have base roles and other roles can inherit the permissions from those. We'll get into this a little bit later, I think, but the gist of Hasura's permission system is that when you issue somebody a role, in the token, you have to give two things. You have to give the role that they use by default. So if you think of a manager of a store, their default role would probably be the store manager. But you would also probably want to let the manager assume the role of an employee for impersonation purposes, right? Just in case they wanted to view things as though they were an employee or act as an employee. And so you say this user by default for all requests makes them as a manager, but they're allowed to make requests as an employee or a manager, and you can set the role if you want to change it per header. And then basically inherited roles takes that a little bit further, where you can define a sort of base set of roles and then have roles that inherit all of the permissions of the super role, and they're all a little bit different. And then there's a third way, which I think Jesse also might show today, which is using the database. So with views, where you can use views to have, for a single role, like just only user, you can use views to emulate like a different set of like permissions per role, if that's roughly what you're asking. So there's a couple different ways to do it, and that was a lot of information, but hopefully we'll get to cover enough today that maybe you'll feel like you have a solid understanding.
Yeah, that's awesome, Gavin. I actually had forgotten about the view thing. I think it's probably something that I can quickly show now. Just in the context of a user wanting to be able to obviously browse this marketplace, like they want to be able to see the names and the descriptions of things so that they can make a purchasing decision. The key thing that we just have to make sure, like we covered earlier, is that they can't access the secret unless they're someone who's purchased it before. And so one really powerful way we can do that, sort of using the database and the functionality supported by Postgres, is to create a view of the items table that doesn't even allow the secret to be exposed. So this is actually included in the schema. If you're following along, you've got the public items view. And you can see that this view is just defined as basically all of the columns from the items table except for the secret. So this data set doesn't even support the ability for this value to be shown. If we look at that inside of Hasura, you can see that, you know, we've got an item listed here. And again, like no secret value is shown, even though this is entirely derived from the real-time contents of our actual item table that has our secret in it. And the neat thing here is that views in Hasura are sort of treated almost as if they were a top-level table, with the ability to have like an individual set of permissions applied to them. So if we look at the public items view and the permissions that are defined on that, here we can say that if you look at the row select permission, I have no check. There's no condition that needs to be met for a user to view these columns because secret's not in here. So yeah, that basically allows you to have kind of like projections or views of the same data, but with you know, different pieces of it being exposed based on different conditions. So if we go back to user 2 who didn't have access to the secret or any items, if this user were to query the view public items and ask for, say, the name and description and the cost, they can basically, they do have access to this because it's protected, and we could use this to basically, you know, build a marketplace page where they can search for and view different things that are for sale. Contexts here, and we're going to quickly do like a beginner intro, hopefully around the same 10-15 minutes here into some of the basics of NestJS. And then we're going to spend the rest of the workshop basically building out the rest of the functionality for this to be a fully fledged usable thing. Okay. So I'll do the quick, what is NestJS? So NestJS is a TypeScript framework for building server-side applications with Node. It provides some really powerful functionality across sort of an array of different things that are important to enterprises. So it's got strong code scaffolding abilities, which we'll see in a moment. It really provides sort of that missing piece when it comes to code organization for things like testing and isolating your business logic and services. If you take a look at like a typical maybe example of an Express.js application, I'll zoom in on this.
Yeah. Zoom. Okay, there we go.
This is kind of like your standard Express.js application where the app is just basically a top-level object that you connect routes to. And I think a lot of people in the JavaScript and TypeScript ecosystem really just fell in love with the simplicity and power of Express in terms of like, you know, in a couple lines of code here, we've got our application listening and serving requests. but it really doesn't do much beyond that when it comes to helping you answer sort of those more enterprisey scalability concerns when it comes to like code organization, developer productivity, the ability to like have a place where our business logic lives and that we can test it without it kind of all being, you know, just like a route and then a bunch of middlewares chained together. Yeah, we'll kind of explore this really quickly just by scaffolding a brand new NestJS application. The easiest way to get started is to just install the included CLI tool through npm globally, and then we can basically just create a new project, and I'll show you that.
It's maybe worth mentioning for people from other ecosystems that if you're familiar with Spring and Spring Boot, a lot of the design and architecture patterns from Nest are sort of a one-to-one mapping to Spring, and even things like the injection API for DI that it has are almost verbatim identical to the JSR spec for dependency injection.
Yeah, for sure. That's a great point. I've seen a lot of overlap having done work with .NET Core and that ecosystem as well, where we'll look at the decorators, but yeah, similar stuff where you've got kind of annotations and things like that. So let us generate a new application. So I'm just going to do nest new example app. Let me quickly try to get my terminal sizing. I always forget about this. Where is it? There we go. A little bit better. What's really neat here is that you'll see when scaffolding a new application, and also when we actually integrate with or interact with the CLI later to scaffold out new components for our application, that we always receive a preview of like what will be changed inside the file system. We also have support for 3 of the different popular package management utilities in the ecosystem. I still tend to use Yarn for a lot of stuff, so I'll just quickly show with a Yarn selection for here. And this is going to scaffold out our application for us. Great. So let's take a look at what we got here. One other aspect of sort of the benefits of using Nest or a more mature framework like this is just around sort of the out-of-the-box developer experience. So, you know, going to our package JSON and taking a look at some of the scripts that we have built for us automatically, you can see that things like building like production bundles of our application, running tests in different modes, running like a dev server that'll automatically reload as we make changes, or even one that exposes a node debugger. All of this is sort of included for you, and it's set up in a way that it's sort of optimized to work out of the box without you having to sort of think about setting up like Webpacking or like any of the other sort of like tooling challenges that I think are common for people in the Node ecosystem. So just another strength that we see right out of the box. The main file entry point for our application is in main.ts, and it just creates an application based on our app module. So everything in Nest in terms of sort of the code organization and the way that we build components or subsections of our applications centers around this concept of modules. And a module is basically a collection of controllers and services which implement our business logic working together in sort of like a little packaged up way. And this is really advantageous, not just for you as a developer in terms of having like a place where you just know to look for things as you get ramped up in the NestJS ecosystem and you're building your own applications, but it also provides a really powerful way for library authors to build plugins or modules that can be shared and reused and can cover like a huge gambit of functionality. So we'll cover this more as we get into the reference application, but there's plugins for just about anything that you could kind of want to imagine as far as stuff that you can kind of integrate directly into your application.
Could we do could we do like a 2-level zoom?
Oops.
Sweet. All right, awesome.
Is that good, or do you want me to go a little bit further?
Does anybody have any particular permissions on level of zoom? Do we have people who are sight impaired? Speak now in the chat if you would like it higher. Otherwise, we can leave it here. We will wait for about 15 seconds. Okay, it's looking like then this is going to be good. And if for whatever reason you would like the text font size to be larger, just put a message in chat, and we can always accommodate people who have a hard time seeing or are vision impaired.
Awesome. So we'll take a quick look here at
Wait, I love one person who is requesting slightly larger text. Okay. All right, I think with this, we should probably be good. Okay, yeah, cool. Awesome. We're all.
Okay, so we'll quickly take a look at sort of the anatomy of a couple of these components. So you can see right here that our main app module entry point defines some controllers. And a controller is basically a class that implements sort of the routing concerns of the API that you're going to basically be building with NestJS. So you can see here that this class, it's got a controller decorator. And if I start the application up, you'll see there's some diagnostic logging here that I find is very helpful in terms of the routes resolver. Basically, some background processes they're picking up these classes and turning them into an actual Express API that's kind of glued together for us behind the scenes. So you have a lot of control over sort of the concerns of routing inside of these controllers. You can see like right now, this is exposed at the root of my application. So let me quickly split this. So if I curl to the root, I get back a hello world response. If I wanted this, for example, to have a prefix of /API, basically anywhere that you see like controller or get, post, like there's one of these for each of the different types of verbs that you can want to handle in your application. You can change that there. And you can see now that this is being mapped at the /API endpoint. So if I were to try to curl, this is no longer a route in my application. If I did /API, we're back to where we started. Now, one important concept that we'll come back to quite a few times through the rest of the workshop is Nest's focus on solid design principles through dependency injection. So the idea here is that code in any framework, if we were to just write the entirety of our business logic right in the controller methods in here, would get messy and unwieldy pretty quickly. So we often want to break up the responsibility of our code and kind of have like an end-tier architecture where controllers deal with handling the outer layer of routing, and then we want to delegate the responsibility of what happens to that request to some kind of business logic-y thing that we control. So you'll see here that this app controller that handles the request, it has a constructor, and inside of that constructor, we're specifying here that this class requires an app service in order to function. So if you were to try to instantiate this class yourself, like const controller equals new app controller, you would be required to figure out okay, app controller needs this service because the service is going to give us our message back. How do I get this in here? I could potentially manually instantiate it, but that again isn't really a scalable approach. And so a big portion of what Nest is sort of facilitating for us here is the kind of automatic management of our dependencies. So you'll see, like in our module, the app service that we care about, this is the same class here and here, it's specified in the providers, which means that anything else in this module that needs an app service, all you have to do is just put it in here like this. And when the request comes into the application, that kind of gluing of things together will be taken care of for you automatically. This is really neat, especially when we kind of get into sort of testability, because by basically turning these into injectable values, we can provide different injectable values when we want to go and test the application. So you can see here, we got an actual unit test here for our app controller, just as part of scaffolding the app. So this I didn't make this; it came when we generated the application, and you can see here that there's a test that basically sets up a mock application or a mock module, and just asserts there should be some response that we control. Nothing's being overridden here at the moment, so this is basically like a one-to-one of what our real app is doing. But obviously, if we wanted to like have a third-party service, like let's just pretend that the value we want to return came from Stripe or like some database or any third-party thing that is a layer in between this service and kind of what we want to return to the user. So I think that the easiest way to see this is, first of all, actually, I'm going to install one dependency.
I wonder who wrote this.
Whoops. Oh, I got to learn how to spell. So when we're setting up our test module here, we have the option to override different components. So if we wanted to override the provider and we want to basically say, okay, when it comes time to get an app service, I don't want to use the default one. I want to give you the thing that should be returned instead. So we can, for example, provide a new value here. If we want to have some type safety, there's a variety of tools around sort of like type safe mocking in the TypeScript ecosystem. Because we're showing off some of the functionality from the Go Level Up suite of tools, I'll quickly just pull in that, and we'll create a mock of our app service. And here we can replace the implementation of get hello with, my test message. So here we've kind of created like a replacement thing that we can inject into the workflow. And so down here, we're going to override this provider. We're going to use the service mock instead. I'm just going to do one other thing. Drives me nuts. There we go. And now if I run this test, again, all of this kind of came out of the box. I didn't have to think about anything in terms of getting Jest and all of this integration set up. We see that the test is currently failing, and that makes a lot of sense because I've provided a new implementation of this service for my test where we're saying that the message coming back will be my test message. You can see that that matches here. So, we would want to make sure these line up. Run the test again. And we're back in the green. I should probably change this, but you get the idea. So that's kind of a quick look at dependency injection from a high level. This works in a nested fashion too. So the app controller, if we go back there, it depends on the app service in order to get access to this method. But you can imagine that maybe the app service itself needs like a third party like SDK or something because it's going to go grab this from somewhere else. And so this in turn could also have its own arguments injected through the constructor. whatever this is. And Nest will take care of instantiating and providing those dependencies while also giving us access to override them for the purposes of testing and organization, kind of all the way down. There's a lot to cover with this. I really recommend that you also check out Gavin's blog post, where he spent like a bunch more time than I have in this workshop, kind of going into the guts of this with some really deeply nested dependency trees.
Yeah.
And talking about how sort of the symbol mapping takes place. There's some great stuff in here if you're interested in kind of deep diving with this more.
I would also want to say, like, just taking a moment to appreciate kind of how mind-blowing it is to run one console command and then have an entire dependency injection system and be able to just mock arbitrarily nested values and swap out stuff in your dependency chain. Like, the amount of functionality going on here is just, it blew my mind the first time that I saw it.
One last thing that I'll quickly show before we move on to the actual reference application is that beyond just the controllers and services that we looked at, there's a ton of other stuff that it's just, there's too much to cover in one workshop. NestJS also provides exception filters, pipes, which are a way of like validating data coming into your API, interceptors, which are like a middleware on steroids kind of thing. And then also guards, which is a really common kind of question that I think people have when building out an API, is how should I authenticate and authorize access to information that my server could potentially expose. So I'll really quickly show just one more scaffolding command here. With the Nest CLI, we previously used it to create our app, but we can also use it to add components and functionality to our app. So I could do, for example, nest generate guard. And a guard is a type of thing that has sort of a specific interface and stuff around it that allows you to validate whether or not a user should have access to things. So if I generate a guard, we'll call this guard random for the sake of argument. You'll see here that a couple things happened. It created my guard file. It also generated another unit test for me so that as I'm going along, it's kind of helping me keep good coding practices in mind. And so if I go over to the guard, whoops, I think I ran that in the wrong directory. I totally did. Random guard. So you'll see here that a guard is a pretty simple class. It implements an interface called canActivate, and this is a pretty straightforward method. It basically just needs to return either true or false or some future value of true or false if we need to like make a check against a database or do whatever else. We have all the options that we need in here. Because we called this random guard, let's make it truly random, and we'll just say that we'll return math.random times 1 is greater than 0.5. Definitely desirable behavior for your API. Now, if I wanted to apply this, this guard to basically protect either individual endpoints or entire controllers themselves, let me just make sure everything's saved here. Let's quickly add one more route here as the last part of this demo. So let's just say I had one more get endpoint in my API, and we'll say that this is like a secret. Get secret and return this is super secret. So you'll see that I save this. Nest has picked up that I have a new endpoint inside of my application. If I try to access that data, this is going to be at /API/secret. You'll see that I get it back right now because we haven't applied the guard. But another like just really powerful aspect in NestJS is the ability to just basically say when this method is called get secret, we want to use the guard that we made. So we'll do use guard random guard. And now that's all wired up. And now you'll see, yeah, my first attempt, I got it. My second attempt, I'm getting back a proper 403 forbidden resource response from the server, and I can do that, and it's going to give me like a mix of one or the other. The guard itself can also have dependencies injected into it. So again, if you needed to like make a database call or check with Auth 0 or whatever, all of that can happen in here. So yeah, that's kind of a super high level view of NestJS as a framework, some of the tooling and advantages that it offers you. Again, lots of stuff that we won't be covering, but definitely recommend that you check out the documentation and Gavin's awesome blog post. If there's any questions here, quickly field those before we spend the rest of the time with our main application.
All right. Yeah, so if you guys folks have questions, again, we'll do another like 15-30-second break and kind of, ask them now or forever hold your peace / at least until next break for questions. Okay, it looks like we do not have any questions in the chat just yet, so I think we can move on.
Great, awesome. All right, I'm going to close this thing down. Okay. Okay, so back to the application, the repository that's available on GitHub. We're going to jump right into this because we've got a fair bit of ground to cover here. So the first thing that we want to take a look at as part of kind of building out this application is implementing some user registration and login, and then also bringing in some JWT validation as part of that. So in this, it's the same type of thing here where I've just generated this using the NestJS command line interface, and I've created a new module that's kind of responsible for all of my auth concerns. So, the app module, again, this is our entry point. It's pulling in the auth module that's defined over here, which allows me to keep like the controllers, the routing, the services that deal with authentication and authorization isolated. And you'll see here that I've stubbed out a couple different endpoints for us to begin with. So I'll just get our server running here. You'll see that, in my auth controller, I've got an auth/login and an auth/register endpoint. These are pretty straightforward. Again, they're just delegating the actual like business logic over to the auth service, which is injected for us automatically through the constructor. So all of the logic for basically interacting with these things we need to implement is going to happen in the services themselves. So we're just going to jump over there. And you'll see here that both of these I've just left as returning an error saying that they're not implemented yet. So in order to register a user, we obviously need to be able to interact with the database itself so that we can put a record in there for the user that we've created. NestJS is extremely flexible when it comes to again, like what kind of like tooling do you want to use on the back end for doing these types of database interactions or integrations? There's a number of different ORMs that you could pull in. You could use type ORM or deepkit ORM or micro ORM. You can also use Prisma. For the purposes of the demo today, I'm actually going to be showing how we can use the power of the CRUD GraphQL API that Hasura generated with us. So we'll actually be making requests to Hasura from our NestJS backend in a type-safe way for our database integration. So we won't need to worry about an ORM or anything like that for this. You may or may not want to use this approach in a real sort of production application because there are some advantages like finer grained control over transactions and things like that, and raw SQL query builders that you might need to use depending on your app. But for what we're doing today, the ability to just use Hasura itself as our database kind of interaction point will be sufficient. Oh, sorry, go ahead.
I just want to reiterate, I think a lot of folks kind of aren't aware or don't think of the fact that they can use Hasura in their backend API logic, because it already exposes that sort of access layer over your data the same way that an ORM would. And there's a lot of great tooling to, like Jesse said, automatically generate completely type-safe operations. And if you don't need some of those things that direct database connections offer, I would highly recommend just reusing Hasura for your back-end business logic, because it saves you a lot of code that you have to maintain. And it's a really good developer experience.
Yeah, absolutely. We do use a combination of this in our production application for work, where there's a lot of times when, just talking to Hasura directly definitely fits the bill. So there's a little bit of kind of knowledge, I guess, to getting the code generation pipeline set up to achieve this. I won't go through how that works too much, other than it's already taken care of for you inside of the application code here if you've cloned it. So we're going to basically be using a code generation tool that looks inside of all of our classes in our application that end in service.ts, where our business logic lives. And what it's going to do is allow us to write like a GQL query or mutation right in our application code, and then generate like a strongly typed SDK that allows us to invoke these operations and get back the exact shape of response that we're looking for. What do I want to show you next? So yeah, this is hooked up for you. If there's questions later, or I have also opened up like the GitHub discussions section of the workshop repository. So feel free to ask kind of more detailed stuff about this later, but we're just going to kind of assume that it's there for you, and we're just going to start using it. So all of the code generation gets output to our sdk.ts file, and this basically allows us to have a fully typed representation of all the operations against our database that Hasura has exposed for us. And it'll automatically scan our service files and turn these into methods that we can call on our SDK. There's a little bit of work we're going to do here. I'm just going to pull this file in for us. So we've got our SDK file here. What we don't have is the a way to share that SDK in a sort of a NestJS specific or kind of nesty way. So first of all, I'm moving back to the workshop starter here, and I'm just going to generate a module, like a proper NestJS module that's going to house this functionality. So NestJS module, the G is short form for generate. And so that's done some code gen for us. We've got a module in here now. And we've also got our app module, our main entry point, has been updated so that it's going to pull in the SDK module for us automatically, which is really cool. And I'm going to gloss over some of the code here pretty quickly, because this isn't as important. But basically, with the code that's available in the repository in the master branch, there's some boilerplate here around setting up the actual kind of like injectable value that we'll use throughout the rest of the application. So this GraphQL request module is from Go Level Up NestJS GraphQL request. And it has a pattern here for basically allowing you to turn that into something that we can really easily just plug into our other services in order to start using the functionality. So I'm going to go back to my auth service here. And the first thing that we need to do is update the auth service so that it has access to that SDK, because we're going to need to be able to call operations from it that are defined in our GraphQL fragments or operations. So we can just, again, use dependency injection with Nest from our library here. These types are just literally defined in the SDK.module. Just review that later. And so with this in mind, we run our application and we see an error. So the reason that we're basically running into this, and this is a very common type of error if you're getting used to using NestJS for the first time, is that the dependency that we kind of want to use here or have access to, this SDK, it's not being properly exposed to the module that the service, this auth service, is a part of. This is by design so that your modules are kind of like very intentionally encapsulated from one another. So there's no real issue here other than we just need to be intentional about the fact that we want to use this in the auth service. The auth service is part of the auth module. So if the auth module wants to make this functionality available to its providers, we just need to import the SDK module here, which again just comes from this class that we subbed out really quickly. So now that we've done that, save it. You can see that NestJS is happy again. It understands that it will now have access to that service that we require. And that'll allow us to kind of move on here. So let's get some code in here. Okay. Just for the sake of time, I'm not going to hand type out all of this stuff. Please use the GitHub discussions or reach out on Twitter or anything if you have specific kind of questions of implementation code in here. But the main takeaways are that basically we want to implement our login and registration functionality. We're going to pull in some cryptography through the bcrypt library to basically take care of some password hashing and comparison to make sure that we're not storing plain text passwords in the database. And if we take a look at the register user method, so the actual thing that takes care of the business logic on our service, this is pretty straightforward. We're grabbing the request parameters from the request or the body of the request, grabbing the intended email, password, and display name that the user wants to use, hashing that password, and then attempting to insert this user. We're getting an error here on create user simply because we've got it defined up at the top, but we haven't run the code gen step. This is included in the repository, so you just run yarn code gen. And it'll basically make sure that our application's up to date here. And there's something in here that shouldn't be in here yet. I guess we'll jump right into the JWT as well. So upon a user being created, we're going to insert them into the database. And then what we want to return to the person, making the registration call is a token that they'll be able to use with Hasura to make requests against the Hasura instance, as well as to make protected requests ultimately against the NestJS application itself. And so one other module that we're using as part of our application, if I go over to the Auth module here. We'll be using the built-in support that NestJS offers for JWT management as well as Passport, which is like a really popular library from the Express and JavaScript ecosystem for basically taking care of validating requests and things. You don't want to have to kind of repeat that boilerplate or code it again from scratch for all your new applications. So we'll be adding a bunch of packages here. It's going to be Passport JWT, NestJS Passport, and NestJS JWT. And these provide, again, like the community kind of has your back when it comes to off-the-shelf modules that you can really easily pull into an application. So this is just as simple as basically calling the JWT register method inside of our imports for the auth module. We're going to need the JWT module, which we get from NestJS JWT. Man, say JWT 10 times fast. It's tripping me up today. Config service is also built into and part of sort of the ecosystem of NestJS packages. So if you need to basically have control over pulling in environment variables from .env files or loading them from other different strategies, it's got your back here too. So everything that our application needs, I didn't show this earlier, is in a top level .env file. That's got information for both the Hasura CLI, setting up our Docker containers, and a bunch of other stuff. So here we're basically registering the JWT module, and we're just saying that use this particular value from configuration when you need to sign or verify JWT tokens that are coming into the system. So we'll save that. And things are back online now. So at this point, I've got 2 endpoints, login and register. They're fully wired up in terms of the ability to, on the register side, create a new user and insert that information for us into the database. On the login side, it's pretty straightforward here. The user gives us the email and the plain text password. We'll look up the user by email. And if we found them, if we didn't find them, we'll let them know it's not a real email. Otherwise, we'll do some hash comparison on the password. And ultimately, if they successfully logged in, we'll give them their token back. So we've got these as regular post endpoints that we could use like a traditional REST API to basically call. But the idea here, and this is where we're going to start to really get into the integration points between NestJS and Hasura, is that we prefer to have sort of like a single unified API endpoint that users or client applications will connect to. And so we want to make sure that this is exposed kind of through Hasura, and Hasura will take care of the work of basically sending the request to our backend and allowing us to have that sort of unified entry point or API. So the first technique that we're going to look at here, if I can review the README again, is we're going to be looking at how we can basically use Hasura actions to take regular REST endpoints and kind of GraphQLify them in a really straightforward way. And this basically will allow us to call them from inside the Hasura console instead of having to worry about constructing that post request and sending it manually. So if we head over to the tab in the Hasura console, you can see that there's a section here for actions. Great little diagram here as well around, what are actions. They're an HTTP endpoint that allows you to do custom business logic, validation, enrichment, transformation, etc. We're going to create some new actions in here. So when you're creating an action, you are required to provide sort of like a GraphQL representation of the inputs and the outputs that the endpoint that you'll be calling require. So for register user, I'm just going to paste these in. This is in the final master branch as well, so you won't have to do it again.
It's maybe worth saying that essentially all you're doing here is just telling Hasura what post parameters your API endpoint takes in and what the JSON output looks like, except in GraphQL.
Exactly, yeah. We require a handler endpoint that tells Hasura where to send this request to. And this is already hooked up inside of our repository. If we look at the Docker Compose, we can provide kind of like templatable values to Hasura that will allow us to kind of reuse the endpoint pretty easily. So Hasura has inside of it an env value called NestJS base URL, which will basically point to where the NestJS instance is running. I guess one other quick thing, I'm on Linux. And right now, like in the architecture that we're working with, Hasura is running inside of Docker, but we're just doing development against my local machine here. So the NestJS server is running directly on my machine. So this is the Linux Docker endpoint. I believe if you're on Mac, it's like host.docker.internal or something like that. You can just change that value.
It works for you. Both Windows and Mac, but poor Linux folks do not get it.
Cool. So with that in mind, I can interpolate the endpoint that I want to hit for the registration. So it's just going to be the base URL /auth/register, which is where we've put this. We'll create that and we'll fail. I might have had a typo for my notes. Yes, I changed that. Cool. All right. So if we take a look now, we have this action. Actions themselves have permissions on them. so that you can control which user roles should be able to interact with different actions. So we're going to create a new role called anonymous. We want people to be able to hit this without needing to already have an account. And we'll just update that so that they do have access. One other, I think, important thing here is that Hasura has as a configuration value a name of a role that will be the one that's used for any time a user doesn't have a role. So in this case, like I picked anonymous. If you wanted to call it guest, you could do that, or whatever other value you want to use. It's just important to know that this environment variable controls that. So yeah, anonymous can handle this. So if we go over now to our API and I take off all of these, excuse me, I don't want that. So you'll see now that I'm not authenticated. I haven't provided any tokens or secrets or anything like that, but I do have access to this register user mutation that's now being basically proxied. So again, the goal here is that we want to get to the point where we have sort of a single API that our clients are dealing with. And so we're going to call this through NestJS, which will pass it to Hasura. So I can say, I want to register a new user. I want him to be this. My password will be secret. And I want to get back either the error or the token. And because I've already registered this, this email, this is just using a simple database constraint for validation. So in our database schema, we made the statement that emails must be unique. So it's just a really nice way to kind of get sort of the database to be the thing that in some cases is more authoritative for this data. So we'll do a different one.
We have two questions. Mm-hmm. I've addressed one of them. So the first one is, how can we create migration scripts for the action definition? Can we declare the definition using code instead of the console? And I believe that you have these in the metadata folders in the repository currently, right? On the repo, the actions.
Yeah, that's correct. So yeah, to answer that, sort of the desired state of your Hasura instance is when you're working in dev mode, sort of tracked with artifacts that you intentionally do check into the repository. So as I've been going through here and like setting up the action in the Hasura console, kind of doing this stuff, it's written some files out here for me that kind of represent the different actions that should exist, the types involved, permissions, and all of that stuff is automatically modified and kept up to date here. So there is not currently that I know of tools for programmatically generating action representations, but this is just YAML and GraphQL. So there's definitely possibility that tooling could be built around bringing this out of the console and into like your code base directly. We'll see that type of approach specifically right at the end when we get into handling events, which kind of shows like what that technique might look like.
Yeah, and then the second question from Greg. So is there an option of writing Hasura actions in TypeScript or Nest? Is there a code gen option for that? And I want to split this into two things. So I think what he's asking is for writing actions, you mean writing the business logic, right? So I assume that he means, are you limited by what you can write actions in? Let's say no, can you show, if we go to the Hasura web console and we go to the action definition, can you open the code gen panel on our new register user? So we actually have this really cool code gen thing. And if you click that Node Express dropdown, you can see that we have a list of like Ruby, Java, Kotlin, Go. We take the definition, Python, we take the definition of your action types, And we give you handlers in a bunch of different languages that serve as stubs for handling the input and output types, and you just need to fill in the business logic. So if you're not familiar with them, then you can use these starter kits and either deploy them to Glitch or download as a zip. And if you meant, can you write the actions in TypeScript instead of like the GraphQL SDL for the original definitions, like how we had to say that the input type was this in GraphQL? No, you cannot really circumvent that. We have something called the Metadata Sdk, which does let you write Hasura's metadata, like your tables and your actions, yada, yada, in any programming language that you want, and it's all fully typed. And then it generates the YAML or JSON. But for the GraphQL bits, there's no getting around the fact that you have to spit out the GraphQL definition. So I hope that that answered your question in whatever form that it was. And I will link the metadata SDK.
Awesome. Thanks, Gavin. In the interest of time here, so we've kind of covered the first type of integration that we can do, which is the Hasura actions. There's a couple more things that I want to show in terms of remote schemas, event triggers, and scheduled events. I'm wondering if it'd be all right if we just switch to the master branch at this point and we can kind of walk through these different integrations. I'm just worried that if I'm kind of copying and pasting it over incrementally, we're going to run out of time here and miss covering that content.
Yeah, so we can do whatever you like. I don't think we're hard limited to 90 minutes. So if we need to go a little bit over, it'll be up to whatever attendees are interested in staying. You can kind of do whatever you want if you want to switch to the master branch, but just know that you know, we're not going to kick it off at 90 minutes unless that's a hard stop for you.
Yeah, I can definitely go a bit over 90 minutes, especially if there's any kind of Q&A or feedback at the end here. But I feel like it might be worth, just kind of switching over so that we can cover sort of how these things play together a little bit more deeply as opposed to just doing the code copying thing. Because there's going to be lots, I think, of time for people to kind of digest what's in the repo and engage in discussions or Twitter or whatever if they have kind of specific questions, things like that.
Awesome. Yeah, then let's do that.
Cool. Appreciate that. I'm going to close this down. Oh. Sorry, just give me one moment. Oops. Okay, we'll quickly get that going. And I think I need to actually deal with my Docker services from the previous. Already bound. There we go. And I think we should be back at business. Okay. Let's go to remote schemas next. Actually, I just need to quickly run migrate apply. Whoops. Oh, it's inconsistent. Oh, right, because my server's not running. Okay, we'll start our NestJS server. Just going to quickly comment this out because I'll just enable that when we're ready. All right, I think we're good to go here. So remote schemas, let's make sure this is up to date now. Great. Remote schemas are basically an advanced way for you to take an existing GraphQL API that you have and to have Hasura basically analyze the types and the operations and things that remote or external GraphQL server exposes, and to kind of stitch them all back together into a single unified GraphQL endpoint, which is really neat. So NestJS has a really fantastic GraphQL module. If you're interested in building, custom business logic inside of GraphQL, if you have experience doing that already, or maybe you even have an existing GraphQL API that you've built, then this type of integration, the remote schema, can be really valuable for you because it basically provides like a way to have a single endpoint that exposes all of your types and operations, as opposed to with actions where we kind of have to expose things on an operation by operation basis. So like we have to do login and register, and you can imagine that there's a bit of overhead to have to kind of integrate every endpoint individually one at a time. So remote schemas can kind of address that. If we go back to the code here. If we take a look, I've used the NestJS CLI, and Gavin covers this in his blog post as well, to generate a new resource that's going to represent our items and the purchasing ability of those. So that does a bunch more code generation for us. And basically what we get out is a module that's going to be solely kind of responsible. Again, this pattern of separating kind of concerns inside of modules is really powerful. And we're dealing with a new type of NestJS component called a resolver, which again is like a pretty straightforward class, like just a TypeScript class for, sorry, 1 second. I realized why this thing is printing out and it's going to bother me. So this class, our resolver, basically allows us to create our own GraphQL API and implement, any kind of like queries and mutations and things like that we want to have that contain our custom business logic that aren't easily expressible through Hasura directly. So we've got on our resolver here kind of the core value proposition of our application, which is this ability for a user to purchase an item. And so we've exposed that with a named method here called purchase item. And the idea is that the user will indicate the ID of the item that they want to purchase. And we've done some plumbing here to basically ensure that the JWT is being passed around properly, such that we can just inject information about the current user who's making the request without having to kind of capture that as an argument. So you might think about like an endpoint that took in a user ID and item ID. In this case, we really don't have to do that because the current user is captured automatically for us. And that's using a decorator technique. You can look at the implementation of that in the final code base. And so once we have the information about, okay, who's the user, what's the ID that they want to purchase, we can basically implement the logic for that in a regular NestJS service, so-called purchase item. And we're just going to return a response that basically tells the user, okay, you've got this many coins left, and the value, that secret knowledge, the item itself, the thing you're buying, will also be returned to you through this request. So if we look at the purchase item implementation here, I've got an operation at the top that I've created as a GraphQL mutation, named mutation. So this purchase item, it's really interesting here. It showcases the ability to kind of orchestrate multiple things that need to happen as part of a single database transaction. So if you think about the steps that need to occur here, when an item is purchased, we want to modify the total number of coins that the user has left for the person who's making the purchase. And we want to increment the number of coins that the seller will now have in their account. And then we also need to create a database record that represents that purchase happened. So this joins kind of that user, the buyer ID, back to the item ID of the thing that they're purchasing. And the cool thing about having multiple GraphQL mutations wrapped inside of a single named operation is that these are just automatically handled by Hasura as a transaction. So when we defined the schema for our database, if we review one more time these tables, you'll see that we added on the coins column a check constraint that says that the coins can never go below 0. We want to make sure that every user has a non-negative balance. And so we don't have to like think about that really in our service code other than like attempting the operation, and then the right thing is going to happen if this were to be violated. Yeah, this mutation defines kind of the steps there. And then once again, we've run the code gen. So the ability to purchase item is something that we can just call directly on our SDK, which we got through dependency injection. So all we have to do to really pull this off is we want to retrieve the item that the user is trying to purchase so that we can get its cost. And then we're going to pass the arguments that we need to the purchase item. So the buyer ID, the seller ID, which item that they're going to want to do. We're going to decrement the buyer's coins by the amount of the purchase. And we're going to increment the sellers by the cost -1, because we were saying that the platform is going to take a 1 coin processing fee. So with all this, we've kind of got it. Again, this is a service separate from, the entry point, if that makes sense. Like this service doesn't care if you call it from a REST, like a traditional post endpoint or a GraphQL resolver or in a CLI even. We've really isolated and made this reusable business logic. So if we go back to the Hasura console here, I'm going to create an item. Do I have users? I can't remember. No, I got to create a user really quick. We'll register one. Okay, we've got that. I'm going to keep this for later. We'll register one more user. So we've got some users in our database now. We'll create an item. We'll associate it to the second user. So this is for user ID 1, first item. And we'll say that this one maybe has a cost of 10. And then let's do like a super expensive one to just demonstrate that constraint will work. So we'll say that this one would be 60 coins that you have to have in order to make this purchase. Sucker. All right. Oh, it's not showing up. Oh, I think I might have to. Oh, that must not have been in my metadata. Sorry, I thought this was hooked up. I'll make sure that that's committed for the master branch. This is. We'll forward the headers so that NestJS or that Hasura will automatically pass forward the JWT, which allows us to make sure that only authorized users are making requests. And then finally, we'll just make sure that the user has access to the values from our remote schema.
So what Jesse has just done when he clicked that button is he has taken his entire GraphQL server and stitched it into Hasura. So all of his NestJS GraphQL API has become part of Hasura now.
Yeah, exactly. So we'll go back in here. Great. So now the mutation that's defined in my NestJS server, like Gavin has mentioned, is stitched in, as well as any other mutations that I might have as I kind of build out the rest of the application. Any queries that the NestJS server might expose are kind of all now attached into one endpoint that I can really easily call. So let's get the item ID. So we're gonna, as user one, we're gonna want to buy. Let's buy this one first because we can afford it. It's only 10. Purchase item.
How many coins does user one have? 50?
Yeah, everyone starts off with 50 as the default value.
Okay.
So both users have 50 coins right now. That didn't work. Apologies. Let's take a look here. Whoops. I'll ask for the error too. If those are coming back as null, there must be an error. Oh, I typed in the item ID wrong. Item ID was, we want to buy item ID 1. Just put a 0 on. Cool. So you can see that this user who's made the request has received the secret back. They now have access to this value. Their remaining coins is now 40. If we look at the users table here, you can see that, yeah, exactly as we expected. This user has 40 coins left. This user has 59 because they received 10 minus 1 as we took a processing fee. And that exchange has effectively happened as part of a transaction.
And Jesse's made one whole not NFT token. Nothing.
It'll be worth something someday, I promise. Interestingly too, if we query now as this user and we ask for like all the items with their secrets, you can see that I have access to that thing that I bought now in perpetuity because there's a record now that joins that through the permission system. So this user can, like, they've purchased it, they can always see it now, which is really great. So that is kind of the, the high level on remote schemas, schema stitching, basically pulling in that GraphQL stuff to your API.
Will you quickly set the user ID to 2?
Mm-hmm. I have to log in as them, actually. 1 second.
Oh, that's a pain. Try to check the admin secret, which should allow you to arbitrarily set the user ID even if you're not logged in.
Oh, that's true. I only need the JWT if we're forwarding to the NestJS side. Did you want to just run a query against one of the existing tables?
Yeah, just run that same thing, but as user ID 2, just to show that they don't have any items.
Well, they'll be able to see the one that they made because it's theirs.
Oh, yeah, that's true.
Oh, and they can see this one because this one is also theirs. So actually, yeah, let's quickly do one more thing here, and we'll attempt to purchase the other item, item 2, as the person who is our first one. So you can see here, I tried to grab this. I haven't formatted the error message in the most elegant way, but you can see that when I tried to do this, that it violated that rule about a non-negative balance because the price on this item was 60. My remaining balance is 40, so it's obviously not something that I can do. And so the database is working kind of in concert with these two other technologies to really just, completely lock down the requirements of like our business logic or our application. Can
you edit that the objects table that has the check constraints and click view it in Hasura? Because it should show the check constraint on the table page. So if you go to modify, I think, and you scroll down, and then you edit that. So there you go. This is a super great technique to avoid doing, like Jesse said, extra business logic and checking this in your code, which is error prone. You can just enforce these kind of constraints at the database level, and Postgres will just kind of error for you, and you'll get back the constraint name.
Awesome. Yeah, definitely one of the great things about working with a relational database and a tool like Postgres is the ability to have it help you with that kind of stuff. It's very powerful. Okay, so that covered everything for remote schemas. These last two, I think, are pretty quick. So we're basically just going to cover the ability to use event triggers, which are a way to have Hasura notify a webhook whenever something changes in your backend. And that can also be used to do some really powerful stuff. So for example, let's see here. We want to send an email, a welcome email to every new user that registers. So we could do that imperatively inside of like our auth service. Like, you know, we could just chain a bunch of extra code in there to have it do that in addition to creating the user record. Or we can split that logic so that the handling of events is sort of separate from the responsibilities of auth, and we can just do it in a notification whenever like the database is modified. So the last thing that we'll show here to kind of glue this all together is the Go Level Up Hasura module. So this is installed again through a community package that I've authored, and it allows you to set up your NestJS application so that it'll automatically expose an endpoint that can be used to handle these webhook events. And it takes care of both handling that, that webhook, validating the webhook is coming from Hasura through some shared token negotiation or a secret. And it'll also take care of routing that webhook to the service that actually implements your business logic, which is really cool. So if we look at the auth events service, which I've created, this is another just regular old service, but the user created event or method rather has this decorator on it that basically says, okay, whenever there's an insert that happens on our users table, I want to run some code and I want to do something like send an email to the user saying, you know, welcome to our platform. Once you have it hooked up, I did another Hasura community call that was specifically dedicated to kind of this integration. So I'm going to gloss over it and just recommend that it's only 15 minutes long. You can revisit that if you kind of want to get exposed to the guts of this a little bit more. But the big takeaway here is that in the auth module, I think I disabled it. Oh no, it's here, auth event service. That's good. Let's make sure that we see it in our output. Yep. So it's part of the diagnostic logs that you'll see as you kind of go through this here. The module basically reports that, yeah, it's discovered an event handler and that it's going to automatically update your Hasura metadata for you. So we briefly talked about how the metadata is sort of the source of truth for Hasura in terms of like the things that you want to integrate with. And so you could configure this event handling system through the portal or the console. And there's like a lot of clicking and like potentially shared values that you have to worry about. But part of the value proposition of this is that it takes care of that by updating your metadata for you. So if we look at the table that we're attaching our event to, which is the users table, you'll see here that there's a block for the event trigger, and it hooked up all of the environment variables and everything that was necessary to kind of negotiate this webhook to be handled. And this was written to this file automatically by the plugin. So you can just, you know, decorate your service methods and then let the tool update your metadata file for you, and then just check that in. And then your entire kind of configuration of the Hasura GraphQL engine is portable. You can apply that as a migration to another system, whatever. So if we go back to the Hasura console, I'm going to just register one more user really quick. Find an older one. Whoops. Did that not get, is it not in here? Oh, sorry, the trigger is not actually registered. So that's the only thing. It updates your metadata, but it doesn't apply it to the server for you automatically. So we just have to do this one more time.
That just got brought up in the chat, actually. So it's good that you addressed that.
It's still not showing it though. That's confusing.
Does the env file maybe have different endpoints for the branches or anything?
Good question. Let's look at. I think everything should be good on master. Don't see a problem there. Sure, everything's saved. Yeah, I feel like we're already over time here. I promise you that this does work, and it's something that is silly that I'm missing. We use this heavily in production application that I work on for my day job and in a ton of side projects. And again, we've covered this one a little bit more in depth anyways as part of the previous community call. So if you want to see the event triggers, that deep kind of integration in action, that video I think is available on YouTube and through the Hasura blog posts. And I'll make sure that this is all kind of completely ready to run the moment you pull it down and you run the startup commands in the repository. What else? The last thing that I want to mention, I guess before we're done here, is that there are two types of events. You can do ones like we were talking about where we react to a change that happens in the database, but we can also do ones that are scheduled. So if we want to do some kind of recurring business logic, so in the reporting service here, if I want to basically, run some kind of like summary of all the transaction history in my system, we also expose a decorator that allows you to create events that'll be run on a schedule. So this one would be running every minute if the metadata was picking it up properly. So that is kind of our fourth and final integration point here for the ability to kind of do scheduled events, which is really powerful, especially because it will help you sort of solve the problem of if you scale out your application, the NestJS instance, Hasura will trigger it in a way that only one picks it up, even if you had like 10 horizontally scaled application instances, which is traditionally a problem that I think a lot of people in the community have hit with some of the cron plugins, where you actually end up having the event run on every instance simultaneously, which is really not good. So another really cool piece there.
Do you want to maybe just add it manually for the sake of just showing how it works? Otherwise, we can go to Q&A, but I think it's really cool.
Let me just try one thing really quick here, and then if not, I will add it manually. Yeah, I'm going to remove it from metadata and then just make sure that it gets put back. Items. Oh no, sorry, users. Let's remove this. And then see if it got put back. Yes. Oh my goodness, I just realized why it's not working. This terminal is in the starter directory and we've switched over to the final project.
That'll do it. That'll do it, donkey.
Donkey indeed. Yarn Hasura metadata apply. I knew it was something silly. I was just getting the panic mode going. Demo fail. Great. And here's our user created trigger and our summarized purchases recurring trigger. So now if I were to go back over and register a new user, that email's taken 6. You can see our email service. It's not implemented, but there is a package for NestJS for node mailers. So if you wanted to hook this up to actually do stuff, but it immediately prints out, here's a message we would be sending to this user with a welcome message. And then I'll leave this running for the cron so that we can answer questions, but we should see it pop up too.
Can we look at the delivered event under the event triggers page just to show that it's been processed? Yeah, so if you expand that thing and then that thing again, then you can see here the request that was sent, and this will keep a whole log of every time an event trigger was fired off, and it makes it easy to see whether it's been delivered, whether it's pending, and what the response was.
Yeah, yeah, absolutely. There's some really great stuff too around like retry logic should like one request fail for like a transient network error or anything that's like, like potentially repeatable. So the plugin also allows you to configure on a per handler or a per event trigger or like a default fallback, how many times it should be retried in the case of failure, what's the interval that it should wait in between. And Hasura takes care of orchestrating all of that and coordinating it with your backend. Handler not found. So that's just because I disabled it when I did that thing. Bring this back. Cool. All right. We'll see some more logs go as that cron job runs in the background, but that kind of concludes the workshop as far as these 4 different integration points. And yeah, if there's any questions or comments or anything like that, I'd be happy to field those.
One feature, ability to filter. Okay, yeah, so somebody commented about basically like filtering before sending events. So they only want to be notified when some certain fields change, not any field. Did we talk about that? Because that is something that you can do.
Yeah, so the event that I hooked up here is only on insert. So we go here. But if you use an update event, so you want to be notified when something changes, like maybe a coin balance or any other like value that's being changed on an existing record, you can basically switch the definition to be an update type and then specify under the configuration columns from the database that you want to basically be notified whenever values in that specific column changes. And we have like access to like generated types that represent the columns. So you could do something like say like const columns, which is a key of users array. If you want type safety on like what the actual column names themselves are, you can do something like this. Oh, I can't type when people are watching. So yeah, so say we only want it to be like, here's all of our column names. So we only want to be notified when columns for coins change. We could easily put that down here instead.
I did not know that TypeScript trick, that key of users array thing. So I learned something new. That's super cool. So he also asks, so can we set such rules for insert as well? Yeah, so these rules are applicable everywhere that they make sense. Like I think delete, one of these cases is one where it just doesn't make sense to watch for specific columns because it's an all or nothing thing. And then he asks, I can check the value change to, for example, only fire the webhook is if the cost is greater than 20. I don't think there's a way to do that, but Jesse, do you know of a way, or maybe you could have, like, you could just in business logic only check?
Yeah, unfortunately, I think that's a limitation of the eventing system inside of Hasura right now. They don't allow you to provide like a filter rule that's applied at the database before the event is triggered through your webhook. So right now, you would just have to basically check and discard if whatever the condition was. You could just like no, don't do any more processing. But yeah, that's something that I definitely I'm looking forward to potentially seeing in Hasura directly in the future.
We have something, a spec called webhook transformers, which is kind of loosely tied into this. And the idea is it's a feature that will allow you to kind of use Golang's templating language to transform payloads like to and from webhook-based services, just in case the data isn't quite the shape you need. So it's not really like what you asked, but it's something along the lines of event triggers that could be useful. So if you're receiving like a webhook from an external, like a third-party service, or you're sending one, you can use these kind of webhook transformers to like shape the data a little bit.
Very cool. Yeah, I look forward to playing around with that. That sounds awesome.
Someone asked, is there a way to add new env variables without restarting Hasura? On that one, not that I know of. Jesse?
Definitely not in like a local development setup like this with Docker Compose. Yeah, that's just the nature of Docker Compose in general. For any service, if you're changing the env, you just have to tell it to start back up again. Everything is like statefully managed in Postgres though, so like changing one env and doing Docker Compose up again should basically restart it and immediately apply with almost no latency. I believe in the Hasura cloud, there's a way to configure and change env. That's correct, right?
Yeah, so you can change the environment variables kind of like willy-nilly in Hasura cloud, though it doesn't make a difference to the user. Under the hood, it does restart the Hasura service. It's a useful tip if your Hasura cloud service ever does something weird or it's acting funny. One of the things you can do is just add a randomly named environment variable, and that will force a reboot of it.
Very cool. Yeah, and Hasura is designed, I think, really intelligently as like stateless service first. Like all of the state management is delegated to an underlying database, which allows it to restart with no interruptions or to like scale in and scale out without any issues if you want to handle more load and stuff. So definitely a cool tip.
All right. Do we have any more questions for today? I want to thank you to everybody who has attended, and especially the folks who are still attending. I had a really good time. I hope that you all had learned from Jesse, as much as I have.
Yeah, thanks a lot for having me, Gavin. This is really fun. Love getting to show off cool technologies, and especially because there's some stuff that I'm particularly passionate and have worked on from the open source side in there. If there are any follow-up questions, or if you want to kind of get into the nitty-gritty of the code more, because I know we covered a lot of stuff in a very short amount of time there, please feel free to use the discussions section of the repository itself. Or if you want to propose new features that we could potentially implement in a future workshop, like actually wiring up email sending or integration with a payment processor like Stripe, so that coins actually have to be purchased, and then we could like update the database based on event triggers from the payment processor. That's stuff we can do as well. So looking forward to hearing from the community. If there's anything that you feel we can chat about more or improve about it, I'd love to hear that.
A closing statement. Someone asked if Jesse is on the Hasura Discord. Jesse, do you want to give your Twitter, your Discord and your Twitter info so people can reach out to you?
Yeah, absolutely. I am on the Hasura Discord server and on Twitter. I'm either Wonder Panda or Wonder Panda Dev on the Discord server, and I'm Wonder Panda Dev on Twitter and Wonder Panda on GitHub. So should be pretty easy to find. I think I've got a panda face on there.
All right, sweet. Well, with that, thank you, everybody. I will say my last goodbyes, and yeah, that I think will be all for today.